So now we're going to learn how to perform arithmetic with three different fractions. So how would you add or subtract three different fractions such as we have in this expression over here? Well, what you're going to have to do for every one of these fractions in order to perform the addition and the subtraction is you're going to have to find equivalent fractions for every one of these fractions that have the same common denominator. So you're going to have to convert these to equivalent fractions that have a common denominator. And a natural choice for a common denominator for this type of problem is the LCD, also known as the least or lowest common denominator for a set of fractions, in this case for three different fractions. Now, how are you going to find the least or lowest common denominator for these three fractions? Well, one strategy would be to prime factorize every single one of these denominators and then use these prime factorizations to find your LCD. So let's see how that would work. Well, first take the first denominator, 14, and ask yourself, can you divide 14 by a prime number? Now, 14 is an even number, so it can quite obviously be divided by 2, and 2 is a prime number. So if you take 14 and divide it by 2, you end up with 7, which is also a prime number. So the prime factorization of 14 is 2 times 7. Now take your next denominator and do the same thing. So take 20, and 20 is also an even number, so 20 can be divided by 2. And if you take 20 and divide it by 2, you end up with 10. But 10 is not a prime number. 10 itself is an even number. So go ahead and divide 10 by 2. And if you take 10 and divide it by 2, you end up with a 5. So the prime factorization of 20 is 2 times 2 times 5, because 2, 2, and 5 are all prime numbers, and because 2 times 2 is 4, and 4 times 5 is equal to 20. Now, take your third denominator, take 6, and prime factorize 6. So 6 is again an even number, so you can divide it by 2. And if you take 6 and divide it by 2, you end up with 3. And both 2 and 3 are prime numbers, so the prime factorization of 6 is 2 times 3. So let's summarize what the prime factorizations are. We have 14 being equal to 2 times 7. 2 times 7. Then we have 20 being equal to 2 times 2 times 5. 2 times 2 times 5. And then we have 6 being equal to 2 times 3. So how are you going to find the least or lowest common denominator out of these three prime factorizations? Well, look at every one of these prime factorizations and try to find the greatest number of times that every one of the numbers that appears on the right-hand side of these prime factorizations appears, and then multiply it into your least or lowest common denominator. So for instance, look at the right-hand side of the prime factorization of 14. How many times does 2 appear in this prime factorization? Well, only once. You only have 1, 2 on the right-hand side of this prime factorization. Now look at the second prime factorization, the prime factorization of 20. How many times does 2 appear in this prime factorization? 2 appears twice, 2 times 2. Now have a look at the third one. How many times does 2 appear in the prime factorization of 6? Well, it only appears once. So how many times does it appear the greatest number of times. Or amongst these three prime factorizations, where does it appear the greatest number of times? Well, it appears in the prime factorization of 20, the greatest number of times. It appears twice. And because 2 appears twice in this prime factorization, in your least or lowest common denominator, you're going to put 2 twice. You're going to multiply 2 twice in this least common denominator. Now do the same for the next prime number, 3. 3 does not appear at all in the prime factorization of 14. 3 does not appear at all in the prime factorization of 20. But 3 appears once in the prime factorization of 6. So multiply 3 into your least or lowest common denominator. Then do the same thing for the next prime number. 5 does not appear at all in the prime factorization of 14. 5 appears once in the prime factorization of 20. And 5 does not appear at all in the prime factorization of 6. So multiply the least or lowest common denominator by 5, because 5 appears once in the prime factorization of 20, and that happens to be the greatest number of times amongst all of the prime factorizations. Now do the same thing for the next prime number, 7. Well, 7 appears once in the prime factorization of 14. It does not appear in the prime factorization of 20, and it does not appear in the prime factorization of 6. So the greatest number of times that 7 appears is once. And now you've exhausted all of the numbers that you have on the right-hand sides of each of these equations. So this must be your least or lowest common denominator. Now, what is this least or lowest common denominator? Well, 2 times 2 is 4. Times 3 times 5 is 15. Times 7. And that is just equal to 4 times 15 is just equal to 60 times 7. And that is equal to 60 times 7, which is going to be equal to 420. So your least or lowest common denominator is equal to 420. So what you're going to have to do is you're going to have to convert every single one of these fractions into equivalent fractions that have a least or lowest common denominator of 420. So let's go ahead and do that. What I'm going to do is I'm just going to scroll down and I'm going to rewrite the problem, and then we'll continue from there. So we have negative 11 over 14 plus 3 over 20 minus 1 over 6. That is the problem that we are starting with. And recall that our least or lowest common denominator is 420. So how are you going to convert every one of these fractions into equivalent fractions that have a denominator of 420? Well, if you've used prime factorization, this problem becomes particularly easy. Because look at the prime factorization of 14. The prime factorization of 14 has a 2 and a 7. But the least common denominator has a 2, a 2, a 3, a 5, and a 7. So what are you missing from 14? Well, you have one of the 2's, but you don't have the other one, so you're missing a 2. You don't have any 3's. You don't have any 5's, but you have the 7. So you would have to take this 14 and multiply it by a 2, then multiply it by a 3, then multiply it by a 5 in order to get to 420. So let's do that over here. Take the 11 over 14 and now multiply the numerator and the denominator by whatever you need to turn the denominator into 420. So once again, multiply it by a 2, a 3, and a 5. So multiply it by a 2, a 3, and a 5. And do the same for the denominator. 2 times 3 times 5. Because 14 times 2 times 3 times 5 is going to give you 420. And you also multiply it by, you also multiply the numerator by the same numbers, because 2 times 3 times 5 divided by 2 times 3 times 5, so basically everything you have in this bracket is equal to 1. And multiplying negative 11 over 14 by 1 is still equal to negative 11 over 14. And to this you're going to add 3 over 20 times, well, times what? What are you going to multiply the numerator and the denominator by? Well, let's have a look. 20, the prime factorization of 20 is 2 times 2 times 5. So we have the 2 and the 2 from the least and or lowest common denominator. We don't have a 3. We have the 5, but we don't have the 7. So you have to multiply the 20 by a 3 and a 7 to get to the least or lowest common denominator. So you're going to have to multiply this by 3 times 7, and then you're going to have to multiply the denominator by 3 times 7. And again, 3 times 7 over 3 times 7 is equal to 1. So here we have 3 over 20 multiplied by 1, which is still 3 over 20. Now from this you're going to subtract 1 over 6. Now you still have to convert this 1 over 6 into an equivalent fraction that has a least or lowest common denominator of 420. So how are you going to do that? Well, once again, look at your prime factorization of 6, which is 2 times 3, and what are you missing from the least or lowest common denominator? You're missing 1, 2, you're missing the 5, and you're missing a 7. So you're going to have to multiply 6 by 2, by 5, and by 7 to reach 420. So multiply the numerator and the denominator by 2, by 5, and by 7. 2, 5, and 7 in order to reach an equivalent fraction that is 420, or that has a denominator of 420. So let's go ahead and solve this mess that we have over here. Let's go ahead and solve this mess that we have over here. So we're going to have the negative 11 over 14. And then here we're going to have 2 times 3 is equal to 6. I'm just going to keep the 5. And in the denominator, we're still going to have 2 times 3 times 5. So we have 6 times 5. To this, we're going to add 3 over 20 multiplied by 3 times 7 is just equal to 21. And 3 times 7 is just equal to 21. And from this, we're going to subtract 1 over 6 times 2 times 5 is just equal to 10. And then we keep the 7, so times 7. And in the denominator, 2 times 5 is equal to 10 times 7. Okay, let's move on to the next line and continue doing the arithmetic. So here we're going to have negative 11 over 14 times 6 times 5 is just equal to 30. 6 times 5 is just equal to 30. Plus 3 over 20 times 21. I will multiply this in the next step. I want to multiply every one of these fractions in all at the same time. Minus 1 over 6 times 10 times 7 is just equal to 7. Now we can just perform the multiplication to get the equivalent fractions in every one of these cases that have a common denominator that is actually our least or lowest common denominator, of 420. So let's go ahead and do that. So here we're going to have negative, because a negative times a positive is going to give us a negative. So negative 11 times 30 is just going to be equal to negative 330. And then for the denominator, you can perform the math if you want, but I guarantee you that 14 times 30 is equal to 420. Because we used prime factorization to arrive at this 30. You can do this at home if you want to confirm that 14 times 30 is actually equal to 420. And to this, we're going to add 3 times 21. We can just do this math in our heads. 3 times 2 is 6. 3 times 1 is 3. So it's 63. And then again, 20 times 21, you can do this math if you want at home. Or I can just guarantee you that this is going to equal to 420, our least or lowest common denominator. And from this, we're going to subtract 1 times 70 is just 70. And then the denominator, again, 6 times 70, you can actually just do this in your head, is just equal to 420, our least or lowest common denominator. And now the math is a lot simpler. We have every one of these fractions converted into equivalent fractions with the least or lowest common denominator, 420. So we can just go ahead and perform the arithmetic. So we have negative 330 plus 63 minus 70. And I could just do this all in one step. So let's say I take this negative 330 and I subtract 70. So a negative 330 minus 70, remember, I don't have to do this in the order that it actually appears. I don't have to add the 63 and then subtract the 70. I can do this in any order that I want. So negative 330 minus 70 is just equal to negative 400. And negative 400 plus 63 just has to be equal to 37. So, or rather 337. So negative 337. So the answer is negative 337 over 420. So once again, negative 330 minus 70 is negative 400 plus 63 is equal to 337. And the denominator just stays at 420. Now, it doesn't appear obvious that this fraction can be reduced, and in fact, this fraction cannot be reduced. And because we have used the least or lowest common denominator, 420, chances are good that the fraction cannot be reduced, and in this case, in fact, it cannot. So this is actually your final answer.